get into the notes. So find the circumference of each circle in terms of pi. So for circumference is equal to 2 pi times r, or you can write it as 2 pi times d, where d is the diameter and r is the radius. So keeping that in mind, we can solve for the first one. So 16 is the radius, so circumference equals 2 pi times 16, and so we get the circumference is equal to 32 pi. And so for the second one, diameter is 16, so then we can do 2 pi times the radius 8, or just pi times 16 to get 16 pi. For number 3, area, pi r squared. So in this case, r is 12.5. Oops. So the area is equal to pi times 12.5 squared, which comes out to, we're going to leave that in terms of pi as well. So that's 156.25 pi. Sorry if my handwriting is a little bit messed up, but number 4, we have our radius is pi over 4. So if you find the area, you should be getting area is equal to pi cubed over 16. And then kind of 5 is kind of working backwards. You're given the area, what is the radius? You want to solve for r. So 25, oops, let me erase that. 25 pi is equal to, and then pi r squared. So you can see the pi's cancel out. Then take the square root of both sides, and we get r is equal to 5. Hopefully my volume is loud enough and you can hear me fine. Alright, and then we have the center of the circle. So you can use the distance formula to find the distance between A and B. And once you have that, that's the radius. So you should be getting 25 pi as the answer. Oops, keep forgetting to write 5. So 25 pi. And how many degrees are in a circle? Well, that is 360 degrees. All right, so there's the do now. Let me just write the answer for 2. You should have got 16 pi for the circumference. 16 pi. All right, this feels so strange. Okay, so now let's go to the notes. Okay, so we did the do now. Talked about area, circumference, and degrees of a circle. So degrees in a circle, there are 360. And so find the measure of each central angle. Well, the central angle is, let me use a different color here. So this is the central angle right here where it says sleep. At 31. So it's 31% of the circle. So we can just take 360, the total, times 0.31. So 31% of 360 will give you 111.6 degrees. Again, I'm writing this with my finger. I think I'm going to buy a stylus pen, but for now, that's what we have. And so you can kind of figure out the rest of it, multiplying 360 by either 0.15 for the other, and then if you go to the entertainment, by 0.18, and then so we get the various angles. I don't think we need to go too much more in detail with that, but the central angle we'll talk about a little bit later as well. Okay, so you can see the little picture here. We have the circumference, which is the distance around the circle, then the radius and the diameter. So the central angle, let's come up with that. So the central angle will be an angle with vertex at center of circle. This writing is atrocious, much like my writing in class. So angle with the vertex at the center. So if you look at P here, let's see, I think we can do I thought we had a highlighter thing. What does this do? Nope, don't want that. P right here. And so then if we look at this angle here, that would be like the central angle. Okay. Then we have a semicircle, which is just a half circle. So if you want to jot that down. Then we have the minor arc. Again, I might be rushing through a little bit of this because I want to have it less than 15 minutes because I think that's the most amount of time I can record. All right, so minor arc is less than half of the circle. And then the major arc is greater than half. Ooh, there we go. Greater than half. And we'll take a look at the picture off to the right. So semicircle is just half. So if we look at this picture here, let's use blue. So this would be a minor arc because it's less than half. The yellow, or the blue, and then the yellow, that would be a major arc. Okay. All right, so we briefly talked about radians in class, but radians and degrees are just two different ways of measuring angles in a circle. And so there's a cool GIF on Reddit, actually on Wikipedia, I think. If you type in radian and go there, you can find a GIF that shows exactly what a radian is, but unfortunately we can't do that right now. So the conversion is 360 degrees is 2 pi radians. So then if we want to convert between radians and degrees, we have this formula. So we start off with our degrees. So if we're in degrees and we want to go to radians, whatever our degrees is, divided by 360 times 2 pi. But we can reduce that. Oops. So really, we're multiplying by pi over 180. And then to go from radians to degrees, we start off with radians, and then we multiply it by the reciprocal, 360 over 2 pi, which again we can reduce to 180 over pi. So I think if we just look at one or two examples of that real quick, I'll just write them right over here. All right, so let's see. So if we have 310 degrees, and we want to write that in terms of radians, so multiply it by pi over 180. And we can simplify that to 31 pi over 18 radians. And you can abbreviate that by just using RAD. So that's to go from degrees to radians. And then if we want to go from radians to degrees, well, let's start off with something 4 pi over 3 times. And now we want to do the reciprocal, 180 over pi. And the way I kind of remember it is the pi should always cancel out when you're going from radians to degrees. So the pi's go away. Then we can do 4 times 180 divided by 3, and we get 240 degrees. So those are equivalent expressions of the same angle. All right, so circles and measures of arcs. So again, we're talking about this. Let me just highlight it right here, this arc right here. So for one slice, well, there's what? How many pieces? 1, 2, 3, 4. So there's 8 pieces. So we can just do 360 divided by 8 to get 45. So 360, let me zoom in a little, divided by 8 to get 45. So that's 45 degrees. And if we want to convert that to radians, 45 times pi over 180. And then we get pi over 4. So pi over 4 radians is equivalent to 45 degrees, and that is the measure of the arc. And so for this one, Pac-Man, we're given that 60 degrees. So if we want to write that in terms of radians, again, whenever we're doing this, it might be helpful to pause it and try doing the problem first. Otherwise, you're just going to go through all of it, think you understand it, and then when you actually try to do it, you're like, I don't remember how to do that. So pi over 180, so we can reduce that. Sorry if you hear my kids screaming in the background. So pi over 3 radians. All right. So here's the conversion chart. So we can see here, we start off with 0 degrees, and then we kind of work around this way. So 90 degrees pi over 2, 180 degrees pi, and so they're all in, 30 to 15 degree increments, depending on where we're looking. Those that are in Algebra 2 right now, you'll get very familiar with this. Yeah, okay. All right, so now let's get into arc length. So arc length is like a percentage of the circumference. So the arc length is now this length right here. Okay. So all we need to do is take 60 degrees. Let me zoom in a little. Makes it easier to write. So let's give some value to this radius. Let's call this, 5 units. Doesn't matter what it is. So if that's 5 units, then we take 60 divided by 360. So that's a percentage of the total times 2 pi r, which, if you remember from the do now, that's the circumference. And so if we multiply that all out, we get 5 pi over 3. Those cancel out, so you get 1/6, and so you get 10 pi over 6, which reduces to 5 pi over 3. And now we'll say, let's see, so let's call this 7 units, and we'll call that 9 units. And so you should begin it. You can check your work, see if you get the same answer. The arc length here, you should be getting 14 pi over 6. And then here you should be getting 3 pi units. Okay, so check to see if you guys get those answers. All right, so you order medium pizza. You want to find the length of the crust of one slice. So we need to figure out what percentage that is. So there are 6 slices. So we can divide that by 360 divided by 6. And we'll just do the first example together. So example 1. So 1/6 of the total times 2 pi times, I think I made an error, yeah, times 2 pi, so the 14-inch pizza is the total, so that should be 7, yeah, so we get 14 pi over 6, which we get 7 pi over 3. And for the second example, let's see, I'll let you guys do that one on your own, but same concept. Oops. Sorry about that. Okay. Dang it. All right, so to find the arc length, I'm just going to give you the answers for these, and then you guys can check what you get, see if you guys got the same thing. All right, so for the first one, let's see, I rounded it, so I included pi. I multiplied by pi to get 49. Zoom in here. 49.7 feet is this arc length here. And then for that one, should be getting, I left it in terms of pi. It will tell you whether to leave it in terms of pi or to round it by multiplying through by pi. So 7 pi units, centimeters. And then the last one, you should be getting 14 pi centimeters. Okay. All right, so tangent lines, I don't think we talked too much about this. Tangent lines, they intersect the circle at exactly 1 point, and they're always perpendicular to the radius. That's pretty important. So always perpendicular to the radius. So right here. So we're going to use that fact. Okay, so the exterior lines in these diagrams are tangent to the circle. So that means they're tangent to the radius. And so that means that they are perpendicular. So if we look at this one, we have a right triangle. So we can just do 90 minus 58. Oops, 58. That will be equal to x. And so we get 42 degrees. Here, we have 2 right angles. And so the sum, there's a couple of different ways of doing it, but it's a quadrilateral, so the sum has to be 360. And we should be getting 50 for our angle. So you can just do 360 minus 180 minus 130. That works. All right, so here we're not finding an angle, we're trying to find a side in this last one. Well, we know this is the radius 3. This is also a radius, so this is also 3. And then we can just use the Pythagorean theorem. So we have 3 squared, let me zoom in a little. 3 squared plus x squared is equal to, so then we have to add those together. We get 10 squared And with a little bit of algebra, we get 9.5. And then this bottom one is very similar. You have to do some distribution because we have the x plus 2 quantity squared. So be careful with that side right here. But you should be getting x equals 15. Sorry about that. Okay. So now we want to find the distance between the centers of the gears for the dirt bike. So we want that length. Oh, that was a pretty straight line. Okay, so pause it and try and figure out how to do it. All right, welcome back. If you didn't pause it, shame on you. Okay, so we're going to draw a line that's parallel to that line. And then, let's see. We know that that radius is 2.4 here. So this is also 2.4. And then we can figure out, so that's a right angle. So then we can subtract that to get 6.9 for this length here. And then that is the same length. So then we can solve for the hypotenuse here. Oops. So we get 6.9 squared plus 26.5 squared is equal to, we'll call that x squared. And so if we solve that, we get x equals 27.4. Okay. All right, then the last thing is, so one of the theorems, theorem 12.3, if two tangent segments to a circle share a common endpoint outside, then those two segments are congruent. So if we look at this picture off to the left here, you can see that segment and that segment are both tangent lines, and they share a common endpoint, namely that one. And so then, by this theorem, we can say that these segments are congruent. Hopefully these videos get a little better as we do them. Okay, so in this example 1, we can see AB and CB are both tangent lines and they have the same endpoint. So that means that C is equal to AB. So I'm going to just put a little tick mark here and here. And so C is 16. Then we can solve for B using the Pythagorean theorem. And we get that to be 20. 12 squared, the square root of 12 squared plus 16 squared, which is 20. And then A, well, they're both radiuses of the same circle, so that's 12. Okay. And this one over here. So just taking a look at what's congruent. So we have that and that are congruent. Those two segments are congruent. And those two segments are congruent. So that's 4. That's 3. That is 2. So x is 5, and you should be getting the perimeter to be 18. All right, and the last thing, find the perimeter of the pentagon. So I'll let you try and figure that out But the answer is 52 feet. All right, so that's it. Hopefully I didn't make any errors. If I did, you can let me know in Google Classroom comments. So the homework is attached. So what we'll do then is you'll see this tomorrow. Then you can do the homework and then submit it by Wednesday at, again, 11:59 p.m., excuse me. And then I guess Thursday I'll put up the answers, and then you can check your work, and then we'll kind of do it like that. And then on Wednesday there'll be some kind of, I haven't totally decided what we're going to do yet, but we're not going to learn something new, so this will be reinforced. So we'll do one lesson, then we'll reinforce that lesson, and then we'll move on to the next lesson. I think that will be a good pace, and if it doesn't work out, then we'll adapt and change. All right, guys, we'll talk to you later.